Well, welcome to the lecture of Chapter 2. In the class, we're talking about network and defense countermeasures. Well, this week we're going to talk about types of attacks. So hopefully what we can do is describe what some of the most common attacks are, how they're executed, maybe some basic defenses against it, how to configure a system to prevent maybe denial of service, configure a system to defend against Trojan or against buffer overflow attacks. You're like, oh my gosh, we're going to learn a lot of stuff. So, denial of service attacks, there are several different parts. Now, what is a denial of service? Pretty much like it says, I'm going to attack a system in such a way that really denies valid users from having access to the system. So if it's a web server, somebody's hitting this site so much that the web server can't respond to your request at the server. If it's logging into a school system, it's driving so much business or requests to the server that it can't respond to your login request. So it's a way of just denying service to whatever application you're looking for. And as you can tell, there are plenty of ways of doing it. And we're going to talk about probably most of these. So denial of service is like I said, it is based on the premise that all computers, they have an operational limits, whether it's speed of servers, the number of I/O ports, the bandwidth. Any one of those things can be attacked. In a lot of cases, it uses the ping command. All of you have used the ping command to test connectivity of your networks in your networking classes. Well, in this case, if you ever do, next time you get on, go to your DOS prompt, check help on ping, and look at some of the other options that'll tell you. And basically, it allows you to increase the size of the packet, increase the amount of time you have to wait for a reply. There's a lot of things you can do to it, and attackers have used this basic connectivity command into, I can't call it a weapon, but it definitely is a tool that they use. Now, a distributed denial of service just means it's still a denial of service, it's variation, but what it's done is it's launched from multiple clients. So it's getting 2, 3, 4, a million computers to attack at the same time. Now, it's definitely harder to track because most of the time you're using what they call a zombie machine, a machine that it's not you. You've scammed an IP address, so you can't get access to, you can't trace it. Now, from your networking days and from Chapter 1, you got the TCP protocol, a very secure protocol for data communication. But what TCP does is it has what they call a three-way handshake. So somebody wants to get in, it gives me a request to log in. The server responds with an acknowledgement of that, and then you follow up with a final lock in the agreement. So there's three conversations take place. But what they've taken advantage of is taking these initial SYN packets, and maybe they don't wait for a reply, or they put so many SYN packets in there that it can't connect. Now, there's several ways of addressing these matters. Some of them easy to implement, some of them not so easy. Microblocks, where I'm allocating just a small amount of time to allocate to a SYN packet. Because usually we'll make a SYN request and we may wait several minutes for a reply. Well, what happens if I shorten that time interval so that I can not test that? So it would be something that you wouldn't take up all your system resources waiting. Bandwidth throttling. If I notice that a certain application is where an IP address is taking too much resources, I can reduce the amount of bandwidth that resource is taking from the whole system. So I'm giving it the full bandwidth of a network, of a pipe coming into the server, throttle it back. Send cookies. I can actually have cookies that, pretty much like what does a cookie do on your web page? It tracks information about you. Well, if I embed a cookie in my initial request to log in your system, I've got some information that I can go back to. So there's several different ways of handling these, and some of them are harder, some of them are easier to take care of. Now, a Smurf attack, again, it's another packet, but it uses a ping command, and as you can tell, it basically what it's doing, it is spoofed an IP address. So it's attacking, but it's using a ping command with a spoofed address. So it's gathered information about the network, stolen an IP address, and it's attacking that network. Now, ping of death basically says, hey, most machines can't handle oversized packet. We know that there are packet sizes, and sometimes if you send too much, the systems can't handle it. Now, most systems today have patches put in place, so to eliminate this problem, just make sure that your systems have the latest and greatest software up to date. And most current operating systems automatically drop packets that are too big. Now, UDP, you remember UDP, TCP, and UDP. UDP does not ask for very validation, right? So it tries to say, hey, I'm going to flood. So think about it. I've got a packet that doesn't ask for data, but what happens if without the respond the acknowledgments, I'm spending smaller packets going out, but remember when you first brought a machine, when you don't know somebody's MAC address, what do? You flood the system with a message. Well, guess what? If I start flooding networks or packets through the network with several either ping commands or UDP, just by the nature of doing that random sending out to every single packet, it becomes a problem. Now you've got HTTP post DOS, the denial of service. It hangs a server because it basically when you do a web page where you do a response, you click on something, you want relatively quick response. What happens if I give you a very slow response and just kind of really slow that, by just not giving all that information in a timely fashion? Permanent DOS. Now this one can damage this, but because it often attacks the firmware. It definitely is something that don't see as much of, but it goes through. There's a distributed reflection DOS. Now it uses other routers to try to execute that DOS. So, because what happens when I send a broadcast message, I'm still looking for information and I have to broadcast that to other devices. Well, I can kind of prevent that from somebody trying to use my router to spread, this denial of service attack. I just make sure I don't forward my broadcast packets. And most of your routers don't do that, but you just got to make sure that what router you're doing it's configured to do that, to not forward that. So just give you a rough idea what a distributed reflection one is. I've got it attacking it and it requests information of target's IP, it's spoofed an IP address, it makes a connection, and it hits the internet, and the internet tries to hit that same target. So it's getting multiple routers to attack your device. Now, granted, there are some tools that are used in these attacks, but I also think that using these tools or understanding these tools can help you defend against them as well. Now, which is part of the problem. And in Chapter 1, you saw that some of the reason that these kind of attacks are widespread because the facilities, the tools to use it, are widespread and relatively easy. What I recommend, and I'm probably going to assign in a maybe even this chapter, is to build a virtual machine and download some of these tools to play with, to see how they work, to operate with them, to play games with them. Some of you may have VMware Workstation. I think I sent a request the other day to see who has that. If you don't, I'm going to post instructions how to do VirtualBox and process to that. So I'll give you that and give you maybe a Microsoft Windows 10 access so that you can play some games with some of these tools, because I think it helps you not just to read about them and take tests about them, but also to play with them. So low orbit icon cannon and high orbit ion cannon are two tools. DOS HTTP is a common tool. Some of these are real world. These are attacks that actually happened. And the book goes into great detail into each one of these. And I think it's good for you to go through and research these and read them and see how they were attacked and what happened. But now, how do I defend against DOS attacks? One is basically understand how the attacks happen. You want to make sure you configure the firewall to disallow incoming protocols. But sometimes disabling incoming protocols or all traffic may not be a practical solution. Disabling forwarding of directed IP broadcast packets. So don't let broadcast packets go beyond your router. Make sure your virus protection on all your clients, not just your server, but every single PC are up to date. Make sure your software, because every one of the operating systems sends out security updates. You want to make sure that they're all up to date. And then you want to make sure you've got policies set up for your companies to make sure that employees know the risk and the penalty for downloading software and potentially spreading an attack. So let's look at defending against above overflow attack. Basically, it's definitely more common than DOS a few years ago. Still a threat, but probably not as much. But every computer has a buffer, right? It has so much memory that it allocates for doing things. Based on the design of your software that you're using, an application, some programmers are lazy and don't do checks that you do a buffer overflow, which then means what? If I would attach a virus to an end of an incoming packet, maybe I can go beyond where the buffer is and implement or release my virus into your system. Of course, it's a little bit more difficult because why? I need to understand a little bit about the application, the software behind the application, to see if there's any errors, things I can attack. So I got an attacking machine, I got a message here. The target memory has only a limited buffer, but now I've got this extra data. It's just loaded into memory. It just goes. So you may crash another program. You may just go into spare memory and just sit there because it's not cleaned up. Nobody knows it's there. Now, how do I get against IP spoofing? Again, you want to, the IP address spoofing is used to gain unauthorized access. Source addresses, the packets are changed. It's becoming less frequent than it was in the past, but potential vulnerabilities with routers are external routers connected to multiple internal networks. You want to minimize the number of external routers. The campus here, I think, has one external router to all our internal networks. Make sure the proxy firewalls that use IP source addressing, you want to make sure that authentication is done. Routers that subnet internal networks, you want to make sure that you got to be careful about internal networks. Unfiltered packets end up being a case. Defending against a session jacking, stealing somebody's, taking over a TCP IP section. Often you may have heard it called man in the middle. It basically means a hacker gets access to a target machine and he kind of gets in the middle of your transmission, your TCP session, gathers the data, strips it, maybe delays it a little bit, and moves on. The best way to defend against that is make sure you encrypt the data that you're sending on your network so that the hacker, even though he may be in the middle, seeing everything, he can't read that data. He's just going to go on to something else. Virus attacks now, they're probably the most common, and basically they can be propagated a couple of different ways. Scanning computer, for network connections, reading email addresses in your address book and sending to everybody. The book goes over, several different types of examples of virus attacks in the fake. I recommend you reading those. Now, how do I protect against it? You want to make sure that every computer you got is using some kind of virus scanner. If you don't know whose the attachments are, don't open it. Maybe establish a code word with friends and colleagues to say, okay, what can I, is this valid or not? Is this a valid email from someone? Maybe don't believe all the security alerts sent to you. Just be a little leery and verify before you follow through and follow all the directions of the security. I know it's kind of a little bit different security class saying, well, don't believe all the security notices you get. But just be leery. Be cautious. Trojan attacks, of course. Again, it looks harmless when you first get the email or something, but inside is hidden some harmful software. Maybe they install a keylogger system or spyware. Maybe it deletes files. Maybe it leaves a back door to a hacker to get in later. So that's an interesting thing. Now, of course, Trojan horse students are strongly cautioned against attempting to create any of these Trojan horse scenarios. Release of this type of application is a criminal offense and is likely to result in prison sentence and civil penalties. So, in this class, be very careful about some of the tools that I'm going to have you download. That's why I want you to set up a virtual machine to play games with it. So one, you don't destroy the machine you're on, and two, you kind of isolate yourself from everything. So just be careful. So in this chapter, we talk about some of the most common stealing sessions, virus and Trojan attacks, denial of service, distributed denial of service, and buffer overflow. Some solutions are easier than others. Some require more knowledge of the software that's being run, but in either case, there are ways to try to slow the progress of somebody trying to attack your system. So I've hopefully, I think it's different defenses, antivirus, router configuration, email policies and procedures. Definitely monitor your network traffic. Make sure your patches are up to date and keep systems up to date. Defense against DOS systems, proxy servers, policies and maintenance procedures, against Trojan horses, policy for email attachments and downloading software. Otherwise, if you don't know what the attachment is, don't download it. If you don't know who it's coming from, don't download it. And then, of course, you want to monitor all that. And against buffer flow, again, system updates, and keep the security patches up to date. But make sure these security patches are from a reliable source. So hopefully that gives you a rough idea of the material in this chapter. And if you have any questions, give me a call. Thank you. Bye-bye.